I want to start off this unit by talking about savings annuities. So again, annuities means that we're making regular and equal payments into some account. So the regular means in the same period. In other words, every single month I'm doing it, every quarter, every day, every week, something like that, right? But I'm consistently putting in money at the same rate. And equal will just mean that my payments stay the same every time. Okay, so we're going to be looking at these savings annuities, which are going to be very similar to what we might see for either maybe we're saving up for a down payment for a house or a car, or maybe we're just saving for retirement or something like that, and we're getting interest on that periodically, just like we're putting in money periodically. Okay, so this is, again, very different than what we did in the last unit, where we were just putting some amount of money into a bank. Most of us do not have $1 million to stick in the bank and live off the interest. Most of us are putting smaller amounts into savings accounts or retirement accounts and slowly building that up with interest over time. Okay, so again, in order for it to truly work as a savings annuity moving forward, we're going to need to make 3 assumptions about this. One is, the first 2 are the ones I was just talking about. Our payments stay the same every time, and they stay on a regular schedule. In other words, I don't skip any months or weeks or whatever it is. If I say I'm going to put in $100 every month, it stays $100 and it stays every month, right? So those are the first 2, and then just the last one is this assumption that we are going to let it sit there earning interest after we've put it into that account in order for our future value to actually be what we expect it to be. Now, all 3 of these can be broken, and that would be a topic for an actual finance course. This is just a math course where we're trying to learn some basics about this. I will save that for some other course. So we're going to be making these assumptions all the way through this unit. Okay, so just to make sure that we're following what's going on here, let's start with nice round numbers here. So if I make a plan to save $100 every month in an account that gets 12% annual interest, let's figure out how I would actually get what that account's future value is going to be, to actually see how much money I would have in that account over time. Okay, so first things first, let's make sure that we can figure out, okay, if I'm making monthly deposits and I'm getting my interest compounded monthly, I'm certainly not getting 12% every month. How do I actually figure out what it is per month? Oh, remember, if they say 12% is an APR, which is what we can assume here, then we just divide by 12 because it's monthly in order to get how much we would be getting in interest per month. So we just take that 12%, divide it by 12, and I get 1% per month. As we already talked about in the last section, that actually turns out to be more than 12%, but that's because of how APYs work. Okay, so here would be a simple thing, very similar to what we might call an amortization table. That's basically has one column that's telling us, what time period we're in. So whether it's month 1, 2, 3, or 4. Another one that says what we started with at the beginning of that month. The last one saying what we're ending with at the end of that month. And in between, we'll have how much interest we would have earned and the amount that we're putting in that month. So again, just kind of making sure we're following how all these numbers work. In that very first month, we started off with nothing. And so, of course, we didn't get any interest off of that. And then we put in $100. So that payment into the account will get us up to $100. And so at the beginning of month 2, we will have $100 in that account. And so we are going to get interest off of that. 1% of $100 is just $1. And I'm going to be putting in that $100 actually every single month. So I might as well just put that in here. Okay. And so when I add up this row, 100 plus 1 plus 100, I actually get what the account will have in it at the end of month 2. Okay, so now if I go over to month 3, I'll have $201 starting at the beginning of that month. And I'm going to get my 1% interest off of that, which will be $2.01. And then if I add up that row, $201 plus $2.01 plus the $100 that I'm going to be putting in every month, that will get me $303.01, which will then be the beginning amount for month 4. Now the 1% interest is going to be $3.03, right? Because no bank is going to give us 1/100th of a cent of interest on that, right? Like if we actually calculated the 1%, it would be 3.0301, but that's irrelevant here because we're doing financial math where we can't go smaller than pennies. Okay, so now if I add up this whole row, I'm going to get $406.04. Okay, so that's how we end up actually constructing these tables. As you can see, it's very like algorithmic. You just kind of do this same procedure over and over and over again. And if I wanted to start doing this, you know, as a 20-year-old and then see how much money I would have in my account when I retire, I would be spending days doing this calculation. So as you can imagine, we either need to set up a spreadsheet to do this for us or use a formula. Honestly, both are kind of easy. So I'm going to go ahead and present that formula in the next example and then go through a couple of examples of actually doing those calculations with that formula.